Hello everybody and welcome to my week 3 assignment in my master's program for computer programming dealing with data structures. Yeah, very interesting subject to say the least. Okay, so I'm a little bit late on this. I do apologize. Wasn't my intention, but I really got backed up. Life really threw me a curveball and I'm just getting out of it. So, we'll try to make this brief and hopefully I covered everything that I'm supposed to cover here. So for this assignment, we have to kind of explore a bunch of different sorting algorithms. So, oh yeah, in the background, if you haven't heard my bird, his name is Phoenix. He says hello to you guys. So, yeah. Anyway, so phase one, selection sort algorithm. Use previous data loading program and add sorting to it. Implement the selection sort algorithm for the array, or choose any sort algorithm to implement and need a total of 2. Okay, I think I exceeded this. I'll show you what I mean by that. So phase 2, add another sorting algorithm, such as a merge, quick sort, insertion sort, heap sort, etc. Then perform data collection through those phases by incrementing it by 100, 1,000, 10,000, and 100,000 into an array. Measure the time it takes to sort each of these amounts. Phase 1 to 3, use C++. Okay, so I did this. Now, everything went great except for that bubble sort that you helped us do in the class meeting and stuff like that. I'll show you what I mean by that. I got something going on with it. I cannot, for the life of me, pinpoint it. I have gone through this code with a fine-tooth comb, and it's not doing exactly what we want to do. I'll show you what I mean, but everything else is working great. So I figured, you know what? Sometimes, you run into errors and stuff like that, and rather than just, try to hide them, confront them, and we'll see what we can do with it. Do a performance analysis, write everything down on an Excel spreadsheet so we can see what's going on, basically, and take a look at the differences. So I did that. All right, so I'm going to skip to the end and then we're going to go back to the beginning if that's going to help, because I want to show you something right now with this. So, with the sorting algorithms, I did find some stuff here. So I ran 4 of them. I did the standard library, bubble sort, which was the 2 basically we did. I did a quick sort and a selection sort. Both of these, I should say all of these around at 100 pretty much were the same. 0 milliseconds, right? Then I did 1,000, and they seemed quite the same, except bubble sort got 0 milliseconds. So on the low end of things, they seem to be running pretty parallel to each other in performance-wise. Now here's where it starts to differ. So at 10,000 random numbers, the standard library finished at 16 milliseconds, which I thought was pretty good for the standard library. Bubble sort, 0 milliseconds. No way. I don't believe that for a second. Something's going on with this bubble sort, and it's not providing me the time in milliseconds. And I went through this code, and I can't find it. And I mean, I really went through this code. Quick sort, 2 milliseconds. I was really, really shocked at how fast this worked. Selection sort, 107 milliseconds. Fast, right? Milliseconds, it's not even a second long to do 10,000, units, right? For us as human beings, it's fast. But for a computer, that's an eternity, so that's slowing down a lot. And here's where it gets really interesting. 100,000 sorts. So I had to do these individually. I couldn't run all of these tests at once because it just wouldn't accept it. So I did these one at a time. Now when we go into the demo of this, I'm not going to do the 100,000 of them. I'm sorry, but it's just going to take too long, and I've got many more assignments to do to get caught up. But I will show you enough to show you what's going on with this. Anyway, standard library, 183 milliseconds. Okay, so the standard library just kind of took a dive there. Bubble sort, 0 milliseconds. We got something going on with it. I'll show you the code. Maybe you can point it right away, but I can't see this at all. Quick sort, 27 milliseconds. That is still lightning fast for 100,000 random numbers. I mean, I couldn't possibly do that in my head, could you? Nope. So that's pretty good. Selection sort was the worst. 10207 milliseconds. 10,000 and 10,207 milliseconds. So that's like over 10 seconds, you know. Yeah, so selection sort really bombed on the high end here. So I mean, they seem to be good for certain things. You know, I think some of these, you know, if you're just doing it on an average, you know, maybe the standard library is good for you if you're not worried about a little performance loss. Bubble sort, well, we're still going to have to figure that one out. Quick sort, yeah, it really, really is fast, but you know, it's the way it does things. It kind of chops things up. The selection sort, it'll get there eventually. I think that that's probably going to be my least favorite one. Quick sort's my favorite one. So my analysis is this: they're pretty much built for certain things. You know, quick sort is for speed. You know, selection sort is for, you know, making sure these selections get done. Bubble sort, you know, it's just the way these things do things. Standard library, well, I mean, that's probably your control unit that you want to take a look at. Now, I'm not sure if I should have did another one or not, but I'm going to stop here. And if I have to, you know, let me know and I'll throw another one in there. But I think this covers everything from what I'm understanding. This is pretty much covering everything. Anyway, let's get into the code. Here it is. So what I did is I followed suit with your demo, you know, on that day, and I kind of elaborated on that. So I did, you know, the header file, C++ file that supports it type of thing. So there are definitely different ways these things work, but there's a lot of similarities. You know, for example, you know, your bubble sort, if you look at how it works, you know, we have this in a nested for loop. And at first I thought that this was the problem. I was like, you know, I wonder if this is the reason why we are getting what we're getting, because if you look on the internet, there are examples, and it is a little the same but a little different. So I'm not sure, you know, what's going on here. But printing of the array out and stuff like that is pretty straightforward. So when we look at this in main, you know, bubble sort, you know, if we do 1,000 of them, we have a clock start right there, and so that clock is supposed to start right before we sort these things out, and it's supposed to end at the end of it, and then we're supposed to be able to print that out. It says 0 every time. I'm not sure what's going on with that. You know, we have clocks start and end, and every other one is in the same position and it works, and I'll go through that in a second. So I cannot put my finger on what is going on with this. Maybe you can see this and take a look at it. I don't know. But anyway, so let's go to the selection sort. The selection sort, it does things a little differently. You know, it has a nested loop inside of a nested loop. But the way it works is a little different. You know, they swap these things out in a different way. They how they step through it is almost the same, you know, if not the same. And it works, but it runs pretty slow. I got the selection sort at the end here. So yeah, this was the one that took the longest for some reason. But as you can see, I have another clock here, clock 2, and it is in the same vicinity as the sort. So I'm not understanding why I'm getting 0 on that one particular sort. It's baffling me. But anyway, now we'll go to the quick sort. The quick sort is pretty neat. You have to partition it, and then you have a low and a high, and it goes through each one of these, kind of like partitions it, and then It says, is this lower than this number, or is it higher than this number? Is this one lower? Is this one higher? So it kind of acts almost like a, I want to say like a very very cheap binary tree, if you want to say. If I'm wrong, can you please correct me? But I like this one the most. I think it's really good. And then the C standard library we have basically in main, and that's, pretty much the way, this is the standard on how we do things here. So anyway, yes, they all do it differently, in different ways. Is any one way better than the other? I mean, that's a subject for debate. I guess you would say no. One, they're not, they all have their advantages and disadvantages, so to say. But I like quicksort because it might take a little bit more coding, but the results are fantastic. And, I mean, as long as it doesn't take that much memory, why not do it? So let's get into this. So what I'm gonna do is I'm gonna pick a common number of 1,000. I'm gonna run through every single one of these, all at once, just to show you it works. Otherwise, if I do these one by one and then do like the 100,000, we'll be here for a minute, and I kind of want to start moving on to my next one. I've only got today to finish this stuff. So anyway, let's build it. Now, at my job, I was always taught, clean your solution. Okay, so we cleaned it. Then build your solution. And we built it. And then we're going to go to debug. And since I know it works, we're going to do it without debugging. Okay. Now, as you see, let's go through this. So, Professor, I basically just followed suit with what we began with on your lecture. As a matter of fact, I used the stuff that you showed us. Now, here's the thing. So, this is the bubble sort, okay? And this is the first part of it. As you can see, it's generating random numbers, right? Goes all the way down, 4,000 of them. And then, boom. Bubble sort time, 0 milliseconds. So now this one here is sorted, right? As you can see, it's sorted. It is sorted. But that one is the standard library. Now this one is unsorted, right? As you can see, it's unsorted. Now it's sorted. Okay? So we sorted that one. And that was the quick sort. Again, 0 milliseconds. We're going to keep going on, and then this one should be the selection sort. And that one's sorted. And that one took a time of 1 millisecond, so that one is the, I guess you want to say, the laziest of them all. So anyway, yeah, so that worked. I'll tell you what, we're going to do one at 100,000, all right? And we're going to do, what we're going to do is we're going to do the slowest one. Why? Because I like you so much. That's why. Because I want to show you that I am a competent person and I can do this. Okay. Anyway, here we go. So we're going to comment all that out. Now this should be the code that's going to get our selection sort. So build. Clean the solution. Build the solution. Haha. And then we're going to go ahead and run our thing. Oh, wait a second here. We got something going on. What is going on here? I've seen this happen before. What's going on here? So, of course. That's the reason why. We'll put a couple extra zeros there. All right. Now don't say that I never did anything for you because this is for you. All right. We're going to clean this. We're going to build it. and we're going to debug it. Look at all of those happy numbers. Man. Yes. You see what I have to go through to get a good grade around here. I'm telling you. Oh my goodness. Boom. Okay, so it stops. Watch this now. I thought there was an error here. I was like, what is going on? Why is it stopping? It did so many numbers, it took that long for it to clear the memory and catch back up. So yeah, this is probably a slower one, you know. But anyway, now you can see it's all going in order. You know, it's being sorted. It kind of stopped at 32,767. We'll just say it went to 100,000. And we got 10207 for the selection sort time. Now, if we come back here and we look, 10207 milliseconds. So yeah, that's right on par. But as you can see, I just wanted to do that one, to be honest with you, just to show you that, you know, I did these tests and I'm not making up the numbers, because I know there are people out there that would do such a thing, but I'm not one of them. Okay, so that's my code. That's how it works. That was the analysis of it. I covered all the bases on this as far as I can. That bubble sort, you know what? Now that I'm looking at it, it didn't. I'm not sure if it sorted those numbers, but here's the thing. So we have a sort here, right? And then we print the array afterwards. So what's the difference? We have a sort here on this one. Okay, so then we standard library time and 5*5. Hold on a second here. Print array. We have the size of the numbers. We have all that. You know what I'm looking at right now? Uh-huh. I wonder. Uh-huh. You know what? Bear with me just for 1 second, because I want to try something. I think we just debugged this code. Hey, can I have extra credit for that? I really could use it. I'm not gonna lie. I'm a little worried about my grade right now. That's why I'm kind of being kind of funny about it. I'm trying to be lighthearted about it. But for int nums2 now, what's going on with this? Oh, of course. Of course. There it is. Okay. Okay, so let's do this. Let's just do the bubble sort, right? I love comments. They make life so much easier. Work's going good, by the way. It's just very, very time consuming right now because we're at a very busy stage, and I apologize for that. Plus, half the workforce is out with COVID, and there's just been a lot of chaos going on. So I do apologize for everything. That's, you know, why I'm so late. But this is fun, you know. You can't neglect your responsibilities as a student either. A master's degree is a privilege, and I appreciate being able to attend this school. Okay, so let's do this. I think we might have fixed this. No. Hold on here. See, so okay, so here's the thing. So we have the array. We have that one, right? And it's printing it out. But look, it's not sorting it. It's not sorting it at all. And that's what I'm trying to get at. So if it's not sorting it, then we got a problem. So one last attempt here. This is the code for the sort, okay? So we have your integers I and j. We have the two loops. This is set up exactly the way that you had us set it up, and it's just not working for me. So I don't know, but I'm going to cut it off here just to show you that, you know, at least I did try to debug some of it. It's just not working. So, okay, so one of them's not working. Any advice would be great. So, and as always, if you like what you see and if you think I did a good job, then, give me a good grade because I can sure use it. That 4.0 grade point average means a lot to me. And I kind of want to follow suit with my bachelor's. My bachelor's, I got the summa cum laude, honor. And I'm really trying my hardest with that. I mean, I've been a 4.0 student, this far. I'm a little worried because I missed that discussion, and I know that's going to hurt me, and I'm hoping maybe you can maybe look the other way. I don't know, help me out. Just one time. I promise I'll never miss another assignment as long as I live. So, but anyway, I'm going to end it here. Thank you very much, guys. Have a wonderful day.